The session is now being recorded. Okay. We need to deviate from the normal mode of doing things, which is basically about 40 minutes of lecture, then or 30 minutes of lecture, whatever, then a class exercise and a lab. We have to talk about the syllabus and how we are going to do things. That is the in addition to whatever we need to do. So let's first talk about the syllabus. So I'm going to share my screen. I have to find the window for my syllabus. Here we go. Okay. So I'm not going to spend a whole lot of time on everything here, but I will be highlighting the most important aspects. If you have questions, you can ask me. My office hours are given here, but they have Zoom links that are shown on D2L. You need to choose the appropriate link. Let me show you that. Okay, before I show it to you, I need to make sure that I'm out of the sensitive pages. Okay. I better use this. It's a lot of time. Okay. So this is the home page as from my perspective, from the instructor's perspective. So you can see announcements here. The Zoom links for the class meetings are all here. There is only one link that is here, and the passcode is here. So you use it every Monday morning. Then I have office hours right after this at 12:30, but it is in on a different link. So you need to use this link for that here. Then I have office hours on Tuesday, for which you use a different link. Then the Wednesday office hours are on another link, and so are Thursday office hours. So don't click on the wrong link, and you will not, if you do that, you will not see me. Okay, so that is one thing I wanted to emphasize. Now that I am on the D2L page, I might as well show you some important things. I know most of you know how to use D2L, but I will still show you some stuff. If you go to content, you will see a large number of folders here. Syllabus related stuff is here. You should watch these videos. Then assignments will be here. Then there are other videos, other folders. There will be a bunch of documents for you to read this semester and answer some quizzes. So these are documents. So this readings folder gives you 7 documents which you must read. Then I'll be posting assignments in this folder, assignments, and the solutions will be posted in this folder, assignment solutions. Labs will be posted in this labs folder, and the solutions will be in lab solutions. There will be examples on some material here. It's not exhaustive, but there are some extra examples. Exams will be in this folder or some other folder. I mean, I'm not committed to this particular folder. I might have exam 1, exam 2, exam 3 as separate folders. Then there are some additional questions that you can try. I'm not guaranteeing that the questions here are in sync with the lectures. So you will see a bunch of questions here, question sets, R1, R2, R3, etc. I'm not guaranteeing that these are exactly in correspondence with lecture 1, lecture 2, lecture 3, and so on. So, but there are additional problems which you can try. That is pretty much what I wanted to show for content. Then under assessments, there are assignments. This is not how you will be seeing it right now, but you will see things like this: assignment 1, assignment 2, assignment 3, etc. The due dates will be here, and you need to submit your assignments through this folder. These are for exams, and then there is a separate set of folders for submitting lab work. Then under quizzes, not all of this would be visible to you. I have hidden many of these things at this point. So every week there will be a class exercise, that is problems which you will work on in groups. So I will open up a class exercise for this week after we discuss the syllabus and talk about some material. Okay. The next week I will be opening up class exercise for week 2 and so on. Then there are quizzes on the 7 readings. They are all available to you right now. You can do them anytime before the deadline. Okay. So the first reading is due on September 8, second one September 15. As you can see, the deadlines are all here. Then before coming to class, you're expected to do a quiz. So before coming next week, actually this due date is wrong. Next week is 30th, right? I mean, class is 30th. So you need to do this before August 30th. So I need to correct this. So this is not due on September 6th. This is due on August 30th. There's already a mistake that I need to correct. So there are so many things you need to do during this course. So we are going to talk about all that, but I just wanted to show you where things are on D12. Let me share the syllabus again. All right. I'm not going to read all this catalog description or course outcomes. Let me try to optimize the whole thing by talking about what this course actually does to you by introducing the material. Okay, that I think will be more useful. So I'm going to show the whiteboard for the moment. So let's talk about what this course is all about. I hope you can all see the whiteboard. Can you?
Yes.
Yes.
Okay,
Yes.
let me see whether I can write on it.
Yes.
not seem to be responding at this. Oh, yeah, okay, now I can do it. All right, let's talk about computer science. I know some of you may not be majoring in computer science, but this is probably the right way to introduce this course. So some of you might be doing IT, some of you might be doing forensics and maybe data science or whatever, but whatever I say now is applicable to this course, no matter what your major is, okay? So don't worry if your major is not computer science, okay? What I have to say now is applicable to all majors because it's about this course. So let's see, what is computer science? There is the word science in computer science. What does science mean? If you look at subjects like physics or chemistry, or biology, what are we doing? If you're talking about physics, one of the things we do is we talk about how things move. So we talk about mechanics. We assume certain things. We are observing lots of things in this world or in this universe, how things move, and then we need to understand that. So what do we do when you are looking at how things are moving, like the famous thing about Newton, I mean, the apple falling to the ground. Why is it falling to the ground? So you make a hypothesis saying, okay, the earth has some gravitational force. So you make an assumption, you hypothesize, you come up with a theory, and then see whether that theory matches up with what you observe. So you are making some observations, form a theory because you want to understand it, and then see whether this theory actually helps you predict new things or explain the current things. And if you find a mismatch, you have another look at the theory and then make some adjustments, and then see whether the new version of the theory will help you explain the new things that you might observe or the mismatches that you have seen. So this theory keeps evolving as you see flaws in your theory or as you see more things anywhere. Okay, so that is how science works. So what has science got to do with what we study? All right, this is my view of computer science. I have not seen this written anywhere, but I believe I am correct. Okay, excuse me, let me turn off this phone. Okay, sorry about that. So what is computer science? Well, you look at humans, people. How do we think? For example, how do you solve a problem such as finding the tax on some material that you are buying, or finding your way from home to the grocery store? Those kinds of things. How are you? You can view all of them as problems. How do you solve those problems? So we make some assumptions on how we are thinking. So we all solve problems, right? If you're planning a party, for example, how do you actually solve that problem? You can view it as a problem. That is, you have to invite people, you have to cook stuff, you have to clean your house, you have to have some entertainment maybe, and then those kinds of things you plan and you hold a party, right? And you hope it is going to be a success. So how do you think through all this? So how do humans actually solve their problems? How do we solve them? And what we would like and what we do these days is actually, instead of solving certain problems ourselves manually, we use a computer to do that work for ourselves. For example, if you are filing taxes, instead of doing everything by hand, you use a tax software, which will do lots of things for us, right? Like figuring out what your refund is or how much you owe the government and those kinds of things, right? So if you have to write a tax software, you need to know how to actually compute taxes. So how do you do that? How do you actually carry out that task? How do you actually solve a problem like finding your way to the grocery store or filing taxes or doing just about anything? So you need to actually figure out how we approach problems. One of the things we need to do is, of course, understand the problem. If you don't understand the problem, you can't solve it. Once you understand a problem, what do? Well, in computer science, what we do is we think that problems are solved by carrying out a number of smaller steps. So to solve a problem, as a person, we understand it first. Then come up with a solution which has a number of steps. So we think in terms of a number of steps. Step 1, step 2, step 3, step 4, step 5, and so on and so forth. If you execute all these steps, you would solve the problem. So you need to figure out what these steps are. For example, if you have to go to the grocery store, what do? Maybe the first thing you do is you go to your car and get into it, turn it on, then start driving. And if you know the route, follow the directions as they are actually in your brain. Otherwise, you look at a map or you follow the directions given by your phone or whatever, right? So you think in terms of a number of steps. So you can say, get into the car. I mean, the first step is maybe get into the car. Second step, drive. Then this is quite vague. What do you mean by drive? Do you want to really break this into a number of smaller steps, like saying, okay, follow the directions as given by Google or whatever. So this is quite vague. And then finally you reach the store, right? So these, you can break this into maybe 3 steps, or you can break this down into even smaller steps. So there are a number of steps involved in solving any problem. So as you are trying to solve problems using a computer, what you need to do is first understand what you have to solve and then figure out a sequence of steps for solving it. For example, let's take a problem that is a little more concrete than going to the grocery store. Let's say you want to sell something. You are a merchant and you are selling something to a customer. So you need to figure out how much you have to collect. So you are a merchant, sell something. A very simple problem. And you have to collect the money, right? That person brings the merchandise to you. You need to figure out how much it costs, add the sales tax, and then collect the money, and then give any change back, and so on and so forth. So this is your problem, selling something. I'm trying to explain what computer science is all about using an example, right? So what is the process? So envisage what happens. This person comes to you with the merchandise, customer comes to you, that is the merchant, with a product. Find out the price. Figure out sales tax. And then figure out total cost, total price or total cost, whatever. Then collect oops, I'm sorry. Well, I'm trying to look for the eraser here. All right. Okay, collect cash, return change or whatever, and give the merchandise, I mean, give the product. So these are roughly the steps that you need to carry out. So what we are saying or thinking is that this is the sequence of steps to solve the problem of selling something. So we are hypothesizing that these are the steps. We are saying that we can break down the whole problem into a sequence of steps. So this is somewhat similar to science, like physics or chemistry, where we figure out a theory to explain what we observe in nature. So here we are saying this is how the problem should be solved. We are going to the minds of people and or the actions of people, and then saying this is how they actually carry out the problem. Now, if you can, of course, this is done manually, but these things could all be done using a computer, as you all know. You all have been to stores and bought things, and you know that nobody does this by hand these days, right? Everybody uses computers to figure out the price and then figure out the tax and all that stuff. So you don't have to do any of this manually, but somebody actually thought through this whole thing and then said, okay, let me find a way for this to be done by a computer, because this is the process that we carry out as humans manually. So we have a theory for how we solve our problems manually and write out those steps. And then we translate this to something a computer can understand. So the computer is supposed to do all of this stuff, which we would have done if there were no computers. So we somehow find a way to express every one of this as instructions to the computer. This is where practice comes in. We came up with a sequence of steps, and then we translate those steps into a way this electronic machine can understand. So we have to write all these steps, and this is called a program. The sequence of steps that you write to make a computer do what a human would have done otherwise. Let me stop here for a second and see whether you have a sense of what we are talking about. If you have any questions. Any questions about this?
Mr. Dayton?
Yes.
So basically, like, it's just like for computer science, like as you said, like if there's a problem, like breaking it down into steps, what to do for just figuring it out.
Yeah, that is the most difficult part of the whole thing, figuring out what you have to do to solve a problem. We do many of these things without actually actively thinking, but we are thinking, but we don't really, we don't analyze exactly what we are doing step by step, because it is so natural to us. It is second nature to us, right? When you drive, I mean, you don't think very actively. When you see red light, you stop, right? I mean, it is not as if I see red light, now I have to stop. You don't think like that. You see, your foot just moves to the brake pedal. That's it, right? Because you're so used to it. But now the difficulty is you have to actually think as to what you did first. What did you do next? What did you do third? That is the problem now. You have to tell the computer, which is an idiot, really. Because it is an electronic machine. It doesn't have any life. It doesn't have any brain, unlike humans, right? So you have to say, well, you have to first find out the price, then figure out the sales tax, because sales tax depends on the price, right? Then you can figure out the total cost. So you have to kind of break down. That is the most difficult part of making a computer do things. So once you figure out the actual sequence of steps, you can use a special language, not English, but what is called a programming language, to express these steps as instructions to a computer. And the sequence of steps that you write is called a program. So what have we done? We are doing something as scientists do. We are hypothesizing that this is how you actually solve a problem and get, and based on that, we get a sequence of steps. And then we are seeing whether our instructions, the program will actually carry out that task. If it doesn't, our hypothesis is wrong, or we didn't translate it properly. So we need to revise our theory. That is where the science comes in. I mean, you form a theory on how you are solving problems, and then we see whether our theory actually solves the problem. Almost all of us will figure out that they don't actually solve the problem. Then you go ahead and revise your theory, revise the steps, revise your instructions, come up with a new version of the program, and then it might do things a little better. You might still not have reached the goal, and you again go back and revise your theory. You keep doing it until you get a program that works properly. So this is the science part of the whole thing. And this is what we will be doing this semester. Looking at problems, figuring out the steps, translating them to a language, using a language that the computer can understand. And this is the hardest part. Trying to figure out what happens first, what happens second, what happens third, etc., etc. So that this is, in my opinion, the most difficult part of this problem this course, or computer science in general, figuring out the exact steps needed to solve a problem. And once we figure those steps, things are a little easier. And when we get a sequence of steps, we call that an algorithm. It is a sequence of steps to solve a problem. Okay. Any questions on these things? So how do you express these steps? How do you actually write an algorithm? Because once you figure out the steps, you can write it as you write the algorithm, and then from the algorithm, you can actually translate that to a language the computer understands. So how do you actually write an algorithm? For that, we need a specific problem. So let's say we again want to revisit that problem of selling something. So we can think of sell something, right? Let's call that problem sell something. The first step of this person coming to you with a merchandise and then saying, I want to buy it, that is a human thing. Let's not worry about it. Assume that we got that merchandise. So first step is to get the price. Second step is to figure out sales tax. Third step is to find total price. Fourth step is to find out, let's assume there is something, once you say it costs you $200, you tell the customer you have to pay $200 to buy this, that person is going to give you some money, right? But that is that could be a credit card transaction. Let's assume it is all cash. If it is all cash, there is, I mean, it's a human thing. You can't really do it using the computer, right? So you assume that you got, let's say it is $210. Then let's suppose the person gave you $220. You have to pay back $10. So there is a step missing here, which is collecting the cash from the customer. So figure out how much to return. So there are some steps missing here, which are actually done manually. The computer probably doesn't have anything to do with it. So at this point, merchandise brought to desk or whatever, customer desk or whatever. And here, collect cash. This, I don't quite know how you can do it using a computer unless you use a credit card or something. So I'm going to just skip this step because they have to be done outside of the computer. But these can all be done using a computer. This could be done using barcode, something. So using barcode, or you can read it from the computer might have actually stored the price, so you could do that. This can be done using a computer. This can be done using a computer, using the price and the sales tax. And if you know the cash that you collected, and if you know the total price, you can figure out how much to return. But actually giving the money back is a manual thing. Maybe the computer is not involved. If you have to pay back $10, you get $10 from somewhere and then give it to him, give it to the customer, right? But these are 1, 2, 3, 4. These are the steps that we need to make the computer do. But these are somewhat vague in the sense, especially this, look at this, figure out sales tax. How do you figure out the sales tax? The computer doesn't know. You have to put details here. Find the total price. That is not good enough. How do you find the total price? Getting the price, you could probably say, read it from a price from the catalog or some such thing. But figuring out the sales tax is something we need to say more explicitly. And how much to return is something we need to express more clearly. So we need to rewrite this. Since I don't have space, I'm going to clear all this. So let's say the first step is to read price from catalog. Let's assume something can be done. But then figure out sales tax. That was our second step, right? We need to figure out how much the sales tax is. The question is, do you know how to? I'm the programmer, right? I have to solve this problem using a computer. Do I know how to compute the sales tax? If I don't, I have to ask somebody. I have to learn how to compute sales tax. How do you compute sales tax? Well, you need to know how much sales tax is. Like, is it 10%, 7%, 5%, 8%, whatever that is? You need to know the price. So if the price is P and tax rate is R, sales tax is this. If this is the price of something, suppose the price is 200 and sales tax rate is 10%, then the answer would be $20. This is in percentage. So if something costs $200 and if you are saying tax rate is 10%, this is how you compute the sales tax. So if you don't know this formula, you have to figure out from somewhere. That is another headache. You may not be an expert in everything, right? But if you don't know something, you have to learn how to do that. That would be another challenge that you will face as you are solving problems. You don't know everything, right? You may not know anything about the hotel business. You may not know anything about the airline business. And you may have to solve problems for those kinds of applications. Then you have to learn how they do their business. So as a computer scientist or IT person or whatever, when you have to write programs, you will have to know the particular business. This is a simple example, figuring out the sales tax, but there will be much more complicated things. And then you will be actually learning not just computers programming, you will also be learning that particular domain enough so that you can solve problems for a customer. Nobody knows everything, right? So don't feel bad about it. Just learn it and remember it. And as you start solving more and more problems in a domain, you will become a pretty good expert in that domain. And then you will be very comfortable doing that. That is how things happen in actual practice. But here in this course, what you are going to do is learn how to carry out, how to analyze a problem and figure out the steps and carry out the task of solving those problems. So let me clear this again. We said sales tax is gotten by multiplying the price and the tax rate and dividing it by 100. So when you read the price from catalog, you have to say it is stored in some variable. So you, instead of writing it this way, I'm going to write it slightly differently. P equals price of merchandise. From catalog. Or you could say read price of merchandise into P. So P is a variable just like mathematics. So instead of writing it this way, I'm going to write it like this. To sell a product, first you need to read the price of the merchandise and store it in some variable P. Variables are very similar to what you find in algebra. Then read tax rate into R3. The third step would be set sales tax equals P times R divided by 100. So S would be sales tax. Set total price, I'm just using T, equals P plus S. So if the price is say $100 and sales tax turned out to be $5, this would be 100 plus 5. That would be the total. Then read money tendered, how much the person gave, into M. Return, set amount to be given back equal to whatever you got from this person minus the total price. So get the price of the merchandise and let that be P. Let the tax rate be R. Then using those two things, you can compute the sales tax. Once you get the sales tax and the price of the merchandise, you can add them and put them into a variable called T. And then if you also know the amount of money the person gave you, suppose it was $105 for total price, and if the person gave you $110, this would be 110. 110 minus 105 would be 5. This is the money to be returned to the person. So this would be our algorithm. So you can see that you are reading stuff from the outside world into the program. So this could be thought of as a program. Only thing is the computer won't understand it. Humans can understand this. This is called pseudocode. So pseudocode has different kinds of things. We will see a couple of things today. The first thing is you are reading stuff from the outside into the pseudocode. So reading the price of merchandise, we didn't know that before, and it can change every time you run this. Every time you execute this, you may get a different price because different things cost different amounts, right? A pen will cost different from a television, that kind of stuff. The tax rate might change depending upon which locality you are. Maybe Minneapolis has one tax rate and Burnsville has a different tax rate. Who knows? So that would be another thing that is kind of unknown. You need to read that in. But once you know P and R, sales tax is always going to be P times R divided by 100. There is nothing special to any, it is not unique to any particular situation. If the price is P and the tax rate is R, sales tax is this. That is set. That is, so we say that S should be set to this particular value. Then if you know S and P, if you know the price of the merchandise and the sales tax, the total price is going to be P plus S. So this is a variable that is set to the value on the right-hand side. You add P and S and store that into T. So this is computed first, and then we store that into T. So the first step is to add P and S. Second step is to store that into T. Here, the first step is to multiply P and R, then divide it by 100. This is the second step, and this is the third step. So this is another thing that has to be read into the program, because how much the person gives you, that depends on the particular situation, right? Somebody might give two $100 bills. One might give $100 and some other $20, whatever. So the amount would be always whatever the person gave you less the total cost. So this is how you would write programs, and this you would translate into a language unlike this the computer can understand. Here it is kind of English plus a few algebraic manipulations, and that is called pseudocode. It is not quite English, obviously, but it is not anything that is so unobvious, right? Most people can understand this when they see this, right? If you know a little bit of algebra and if you know English, you can understand what this means. So that is called pseudocode. It is for you and me, for humans. You write this and then give it to somebody else, that person would understand it, right? Anybody, any questions? So figuring out the steps would be the most challenging aspect of any problem solving exercise in this course. Now let's go back to the syllabus. Okay. So I'm not going to read out all this, but what I want to say is that when you complete this, you will be able to solve pretty interesting problems, and you will be ready for the next class, which is ICS 141. The textbook for this one is written by Gaddis. You should purchase that book. All right. Let's talk about what happens in this course using this table, because we don't have a whole lot of time. This material is actually there in the, some of it is actually covered by videos, which you can watch. So let's go over how you will be graded and what kinds of activities we will be doing using this table. You might remember, we did a bunch of things, so I don't know whether you will remember this. When I showed you D2L, there was a section, there was a under contents that said readings. There are 7 documents, 10, 15 pages each, pretty easy to read documents that give you some extra perspective on different aspects of this field, information technology, computers, and all that. You must read all of those one by one, and for each one of those there is a corresponding quiz. You must take all these quizzes. Each quiz has a deadline. You can do all of those quizzes right now in the next week or so if you wanted to, and then be done with it. But it might make more sense to do them over a period of time. So look at the deadlines and do them. And there are D2L quizzes for them. Each one is 10 points, and then you have a total of 70 points. These are timed quizzes, 30 minutes each. There will be 11 homework assignments, most of them programs to write, and each one is 20 points. That would make it 220, but then I'm capping this whole thing at 210, so that even if you make a few silly mistakes and not get the complete points, you could still get the maximum possible, which is 210. So it is to your advantage that I capped this at 210. Similarly, there are 12 labs starting this week. Every week there will be a lab, except when there is an exam. We have 15 meetings, so there will be 12 labs. Instead of 240, I'm capping this at 220. So even if you make a few mistakes here and there, you could still get the maximum. Then every week, except when there is an exam, there will be a class exercise. Each one is worth 10 points, and for a total of 100 points capped. And before coming to class, starting next week, you must take a quiz. After watching the videos and reading the textbook, do that way for maximum benefit. And this is worth a total of 100 points, again capped. 3 exams, each one 100 points. There is no cumulative final, but the material keeps accumulating. So I'll talk about that in a few minutes. So that is a total of 300 points. So the total is 1000. And your grade will be based on this table, subject to another constraint. For every one of these categories, you must score at least 50%. For every one of those, you must at least score 50%. If you don't, there is going to be a penalty. So the grade may not be what you get over in this table. It could be less. So if you don't get at least 50% for the 3 exams together, your grade will not be more than a C. Okay, read this carefully. Or if you fail to meet the minimum in 2 of these categories, other categories, your grade will not be more than a C. If you miss one category, then grade will be one shade below what you would have gotten here. For example, if you didn't get 110 points in labs, then your grade will drop by, say, from B plus to a B, or a C plus to a C, or C to a C minus, and so on. Then there are 2 important things I wanted to talk about. One is that I mean, we all have other obligations, and sometimes we miss some deadlines, or you might make some silly mistakes, like not submitting a program in the proper way. Instead of losing lots of points, I will allow you to make up for those kinds of silly mistakes by using what are called allowance points. So every one of you has 4 excuses for the entire semester. You can use them at any point in time, but I have to agree to your excuse. And if I allow that excuse, and that is entirely my decision, you would have used up one excuse, but you would get points for it. For example, if you don't have the webcam on when you are doing class exercise, you will not get any credit for the class exercise. You have to have your webcam on, audio on. That is a requirement. When you do the labs, same thing. If you don't have a webcam, you lose points. But if you don't have a webcam today, for example, you can use an excuse point and not lose points for that. That is entirely your judgment, whether you wanted to use it or not. Instead of losing 10 points, you might want to just use one of those excuses. That is a decision you have to make, and I have to agree to it. And after 4 excuses, you can't use those excuses anymore. There are no excuses left, right? Then you start losing points for missed work. But you cannot use these excuses for bad work. For example, if you do an exam badly, or do an assignment badly, or do a lab badly, there is no way that it can be excused. This excuse is only for missing something. I mean, if you, for example, if your assignment is late by a day, you lose 10%. So that would be probably 2 points. But then you could use an excuse and then not lose those 2 points. Any points left, any excuses that you haven't used would be added to your total score, which is not going to be anything significant. 4 points out of 1,000 is nothing, almost nothing. You might want to use it if you need it. Otherwise, just get it added to your total. It doesn't hurt, but may not really change your grade in any way. The second important thing, that is the most important thing about this course, is unlike most courses that you have taken, this course is accumulative. That is, in the sense, what you learned this week is critical for understanding stuff next week. And what you learn next week is going to be critical for understanding things the third week. If you don't master the material in any one week, you will be lost for the rest of the semester. Some students don't believe this, or they don't follow this advice, follow this warning, or heed to this warning, and they don't do well. If you want to do well, you have to work on the material every week. Master that. Otherwise, it's not going to work out. Computer science is like that. It keeps accumulating. The material keeps building up. Every week you have to master it. You have to be patient. You have to master the material, and then only go to the next week. Some students come without watching the videos and reading the book. Then you will be completely lost in class. Okay, so that is the other thing. The schedule is given here. You can read that. I have tried to put the deadlines in a separate table. Hopefully they are correct. I'm pretty good at getting my dates wrong. So be careful with this, but I have tried to be helpful here. And the schedule of coverage and the exams are all given in this part of the syllabus. The rest of the syllabus is all what do you call boilerplate language. You must read all that, but I'm not going to go over those. Any questions? Okay, then there are two things we need to do. One is a class exercise, and then the other one is a lab. So in a few minutes, I'm going to break you up into small groups, maybe 4 students per group, or around that. And then you must have your video turned on, audio turned on. You will be all assigned to different rooms. I mean, the groups will be assigned to different rooms. So you'll have about 4 people in a room. One of you can project your D2L page that contains a quiz, not a quiz, but a class exercise, and then solve that. Remember the pseudocode that we talked about? Most of the work today would be based on that. There is an assignment due next week. It has a problem that is more algebraic. It asks you to write pseudocode. So what I would do is probably show you an example of a one more example of pseudocode, and then let you work on the class exercise. So let's do that. Give me a second. Let me stop sharing this. I want to spend maybe 10 minutes on that, and before we break into small rooms. Give me a minute. Oops. Okay. All right. Let me share this. This is actually the PowerPoint presentation. The challenge is to find the right window from the Zoom. What is it? Oh, here. All right. Okay, I'm just showing you. Okay, when you divide a problem, well, we talked about looking at problems, understanding them. We said we have to get them into smaller steps. You can think of three parts. One is input. That is, what should the solution get from the outside world to do its job? For example, if you are computing the total price of an item, you need to know the price of the item and the tax rate. Without that, you can't really solve the problem. So what should come into the program? That is called input. What should the program produce to the outside world? The program should say what the total price is. It should also say how much to refund, perhaps. Then there is a third part, is actually processing, taking the input, processing it, and producing the output. So it is helpful to think in terms of three different parts of a problem. When you look at a problem, try to identify what the program should get from the outside world. That is called the input. What it should produce, which is the output. And then how to get from the input to the output. That is your processing. So for example, read the sale price. That would be input. Read the tax rate. That would be an input, because these could change depending upon the item and the tax rate. But computing the sales tax, computing the final price, these are cast in stone. They don't change. If you know the sale price and tax rate, sales tax is set. You can't really, you don't have an option. It has to be done in a particular way. Or the computing the final price has to be based on the sales tax that you collect plus the price of the item. This is output, printing the sales tax, the total price to be paid, etc. So this is how you would write pseudocode. Read the sale price into something, read the tax rate into something, and so on. We are not going to work on this today, but this is what you would do with this pseudocode for it to be understood by the computer. We are going to use a language called Python, which will look somewhat mysterious at this point, but we will be starting Python next week. So this is what it would look like. These instructions would look like after it is written in Python. So this stuff, which looks more English than anything else, would be translated into a language called Python, which would look like this. Some of it looks like algebra, right? Sales tax equals sales price times tax rate divided by 100, or final price equals sale price plus sales tax. But something like this looks totally mysterious, and it is, right? But we will be worrying about it next week. Don't worry about it today. Just wanted to give you a sense of where we are headed. There is an assignment that is due next week, Tuesday by midnight, by 11:59 p.m. You can work in a team of 2 if you wanted to, so that you get a little more confidence. As if you want to do that, you have to let me know by tomorrow at least. And you need to say with whom you are going to work with. That is entirely up to you. If you want to work alone, that's fine too. Most students work alone, by the way. That is not a requirement. We went over all these things, like, right? So actually some lines are missing here. I need to fix that. Any questions before we break ourselves into small groups? So I'm going to break you into small groups of maybe 4 students each, roughly, and put you into different rooms. So just go to the rooms and then open up, turn on your webcam and audio, and open up D12. I'll make the class exercise available to you. And once you finish the class exercise, you can go back to the main room. I will have you do the lab individually. My goodness, I'm running short of power for some reason. I don't know why. I have to give me a second. All right. Yeah. So after you finish the class exercise, you need to work on the lab. That will be done individually. I will probably have, I will announce the deadline for submitting the class exercise. You have to turn in it as a quiz, okay? So if you have any questions, ask me now. I'm going to.
For the exercise that we're about to do, does only one person need to submit it on D2L with everyone's name on it?
No, everybody has to submit. Everybody has to turn in. But you can all, you cooperate and then figure out an answer, and then, of course, you can disagree too. That's fine.
Mr. Delton, wait. So after the group exercise, we come back in the big room, or we can get started on the lab?
I will create the individual rooms at a certain point in time. Till then, you can still work on the lab, but then once you get the individual room, you go into that room.
Okay, thank you.
Okay, yeah. All right. It has been a few months since I used Zoom for these kinds of meetings, so I'm trying to get my, I need to create the, okay, how do I create? I thought I knew this very well, but I'm getting confused here. All right. Give me a minute. Breakout rooms. So we have, let's try 9 rooms or 8 rooms, maybe 8 rooms. That would be fine. Yeah. So some of you have just 3 people, some of you have 4. So you should be getting I think you would have gotten a prompt to go into a room. Just go to your room. I will make the class exercise available.